Balanced chemical equations can be written in different ways, such as word equations and chemical equations. In a word equation, zinc plus hydrogen chloride gives zinc chloride plus hydrogen. In a chemical equation, Zn plus 2HCl gives ZnCl2 plus H2. An equation having an equal number of atoms of each element on both the sides is called a balanced chemical equation. Let us balance the chemical equation. Barium chloride reacts with aluminium sulfate to give barium sulfate and aluminium chloride. List the number of atoms of the various elements present in the unbalanced equation in the form of a table. Select a compound which contains the maximum number of atoms. In this case, the compound will be aluminium sulfate. It has 2 atoms of aluminium, 3 atoms of sulfur, and 12 atoms of oxygen. From this compound, select the element which has maximum number of atoms and which is present in only one compound on both sides, that is, oxygen in this case. To balance the number of oxygen atoms, we can multiply barium sulfate present on the right hand side by 3, as shown below. It should be kept in mind that coefficient 3 will be written as 3BaSO4 and not as BaSO4 bracket 3. Again, compare the number of atoms of the various elements present in the chemical equation. As the atoms of both oxygen and sulfur are balanced, we now balance the atoms of aluminium. Now only the atoms of barium and chlorine are unbalanced. We first balance the atoms of barium. Multiply by 3 in left hand side. Thus we get a balanced equation. To make a chemical equation more informative, the physical state of the reactants and the products is mentioned along with their chemical formula. For example, the reaction conditions such as temperature, pressure, and catalyst for a reaction are indicated above or below the forward arrow in a reaction. Chemical changes. A chemical change is always accompanied by a chemical reaction. Reaction is the term used for depicting a change or transformation in which a substance decomposes, combines with other substances, or interchanges constituents with other substances. Let us perform an activity to understand a chemical change. Take a magnesium ribbon, hold it at an appropriate height over a Bunsen burner with the help of a pair of tongs. You will observe that the magnesium ribbon starts burning. Collect the ashes in a watch glass. What do you observe? Magnesium ribbon burns with a white flame and changes into white powder. This white powder is magnesium oxide, which is formed as a result of a chemical reaction between magnesium ribbon and oxygen present in the air. Hence, it can be said that magnesium reacts with oxygen to produce magnesium oxide. Let us perform another activity. Take a few zinc granules in a conical flask. Insert the thermometer and note its reading. Add dilute hydrochloric acid to it. Insert the thermometer and note its reading. Do you observe something happening around the zinc granules? Yes, you observe that gases evolved around the zinc granules and raises the temperature. This shows the formation of gas during the chemical reaction and also shows the exothermic reaction. Let us perform another activity. Now take the lead nitrate solution in a test tube. Add potassium iodide solution to it. What do you observe? You observe that a yellow precipitate is formed. From these activities we can say that a chemical reaction has taken place as change in state, change in color, change in temperature, and evolution of gas. Combination reactions. Chemical reaction in which 2 or more substances combine to form a new compound is called a combination reaction. For example, Coal is primarily carbon. When it burns, it combines with oxygen present in the air to form carbon dioxide. On burning of magnesium ribbon, magnesium combines with oxygen present in the air to form magnesium oxide. In this reaction, two elements combine to give a single compound, that is MgO. Let us take an activity. Take a small amount of calcium oxide or quicklime in a beaker. Insert the thermometer in it. Slowly add water to it. Do you feel any change in the temperature? You observe that the temperature rises. Calcium oxide, also known as quicklime, when mixed with water, reacts with it to form calcium hydroxide, also known as slaked lime. Hence, in combination reactions, two or more compounds combine to produce only one product. Generally, combination reactions are exothermic in nature, that is, energy is released. Combustion. It may be defined as a process where the materials, usually metals, are deteriorated because of a chemical reaction with air, moisture, and chemicals. Let us explain with the help of an example. When the iron materials are kept in moisture for a long time, a brown mass is coated on the iron materials. This brown mass on the iron materials is called rust. Rust is explained in the electrochemical theory. When the iron materials are kept in moist condition, the cathodic and anodic regions are formed. The water vapors present on the surface of iron dissolves carbon dioxide from air to form carbonic acid. So now the surface of iron is covered with carbonic acid. Carbonic acid dissociates to small extent to H+ ions. Iron in contact with carbon dioxide undergoes oxidation to ferrous iron with release of electrons. These electrons move through the iron metal and reach to the cathodic region. At cathodic region, H+ ions gains electrons to form hydrogen atom. These hydrogen atoms react with oxygen atoms to form water. Thus, the overall reaction, iron is reduced to ferrous ions. These ferrous ions react with oxygen to form ferrous oxide, which undergoes hydration to hydrated ferric oxide. Hydrated ferric oxide is called rust. Decomposition reaction. The reaction in which a single substance breaks down into two or more substances is called a decomposition reaction. Let us do an activity to explain it. Take 3 grams of green ferrous sulfate crystals in a dry boiling tube. Heat the boiling tube over the flame of a burner. Observe the change in color of the crystal on heating. It will be observed that the color of the crystals change. Also, the characteristic smell of burning of sulfur is observed. Do you know why this happened? Green crystals of ferrous sulfate lose water on heating. Hence, a change in color is seen in the crystals. On further heating, it decomposes into ferric oxide, sulfur oxide, and sulfur trioxide. Ferrous sulfate breaks down or decomposes to form 3 new substances. Hence, it is an example of decomposition reactions. Decomposition reactions can be classified into 3 types depending on the source of energy for the reaction. Decomposition by heat or thermal decomposition, decomposition by electricity or electrolysis, and decomposition by light. Take about 3 grams of solid lead nitrate in a boiling tube. Note the color of the compound. Heat it in the flame of the Bunsen burner. Observe the change taking place. You will observe that emission of brown fumes takes place. These fumes are of nitrogen dioxide. During this reaction, lead nitrate decomposes to form lead oxide, nitrogen dioxide, and oxygen gas. decomposition by electricity or electrolysis. Let us explain it with the help of an activity. Take up containers. Drill 2 holes at its base and fit rubber stoppers at these holes. Insert carbon electrodes in these rubber stoppers. Connect these electrodes to a battery. Fill the container with water such that the electrodes are immersed. Add a few drops of dilute sulfuric acid to the water. Take 2 test tubes filled with water and invert them over the 2 carbon electrodes. Switch on the current and leave the apparatus undisturbed for some time. You will observe the formation of bubbles at both the electrodes and collected in the respective test tubes. During the decomposition of water, ratio of the volume of these gases is 2:1. Gases 1 by 1 by bringing a burning candle close to the mouth of the test tubes. One tube helps burning of candle while the other tube burns with a blast. From this activity we can say that one tube contains oxygen and the other contains hydrogen. Thus we can conclude that water is decomposed by electricity into hydrogen and oxygen gas. Decomposition by light. Take about 2 grams of silver chloride in a china dish. Place this china dish in sunlight for some time. Now observe the color of silver chloride. You will see that white silver chloride turns grey in sunlight. This is due to the decomposition of silver chloride into silver and chlorine by light. Displacement reaction. In displacement reactions, a more reactive metal replaces the less reactive metal from the latter's salt. It is classified into single and double displacement. Let us understand single displacement reaction with the help of an activity. Take 3 iron nails and clean them by rubbing with the sandpaper. Take 2 test tubes marked as A and B. In each test tube, take about 10 ml of copper sulfate solution. Tie 2 iron nails with a thread and immerse them carefully in the copper sulfate solution in test tube B for about 20 minutes. Keep 1 iron nail aside for comparison. After 20 minutes, take out the iron nails from the copper sulfate solution. We observe that the iron nail becomes brownish in color and the blue color of copper sulfate solution gets faded. Iron has displaced or removed another element, copper, from copper sulfate solution. This reaction is known as displacement reaction. The reactivity of metals can be known from the reactivity series, which lists metals in an decreasing order of reactivity. Let us understand double displacement reaction with the help of an activity. Take 2 ml of lead nitrate and potassium iodide solution in 2 separate test tubes. Gently pour the potassium iodide solution into the lead nitrate solution. As soon as you do this, you will observe the formation of a yellow precipitate. This yellow precipitate is of lead iodide. The 2 compounds, lead nitrate and potassium iodide, react by exchanging their ions to form new compounds, lead iodide and potassium nitrate. Oxidation and reduction. Oxidation is defined as a process that involves a gain of oxygen or loss of hydrogen or loss of electrons and gain of electronegative elements. Reduction is defined as a process that involves a loss of oxygen or gain of hydrogen or gain of electrons and loss of electronegative elements. Let us perform an activity to understand more about these reactions. Take around 1 gram of copper powder, which is reddish brown in color, in a china dish and heat it over a burner. What do you observe? You will observe that after some time, the surface of the powder is covered by the layer of a black substance. When copper powder is heated, it combines with oxygen to form copper oxide. copper powder gains oxygen. Thus, it gets oxidized to form copper oxide when heated. This process is called oxidation. Now, if hydrogen gas is passed over the heated copper oxide, then the black coating of the surface turns brown. This is because a reverse reaction takes place and copper is re-obtained. Here, copper oxide loses oxygen and gets reduced to copper. This process is called reduction. Oxidation and reduction occurring simultaneously is known as redox reactions. Red for reduction and ox for oxidation. The substances that are reduced, that is, provide oxygen or remove hydrogen in course of the reaction, are called oxidizing agents. These substances that are reduced in the process oxidize other chemicals in the reaction. On the other hand, the substances that are oxidized, that is, remove oxygen or provide hydrogen, are called reducing agents. Copper oxide gets reduced to copper, and here copper oxide is the oxidizing agent. On the other hand, hydrogen gets oxidized to form water, and here H2 is the reducing agent. Rancidity. When fats and oils are oxidized, they become rancid and their smell and taste also changes. Thus, the oxidation of fats and oils can be easily observed by a change in their taste and smell. Oxidation of food can be prevented in many ways. Storing food in airtight containers. By doing so, the oxygen available for oxidation becomes limited. Hence, oxidation can be prevented. Sometimes antioxidants are added to food to prevent their oxidation. These antioxidants are oxidized first, which slows down the process of rancidity.